Today, let's explore the core principle of Eggy Code triggers. In the section where we introduced blocks, we mentioned that dragging out an event block essentially creates a trigger. The system can monitor the occurrence of event and then perform actions according to our instructions. Eggy Code works with many triggers to achieve various original gameplay mechanics. A trigger represents a piece of logic, composed of event, condition, and action. The event is the start of the trigger, the condition is the requirement that needs to be met, and the action is the output result of the trigger. To explain a trigger in one sentence, when an event happens if the condition is met, then perform an action. Here's a real-life example. When fall down, if you are hurt, then go to the hospital. You fall down is the event that triggers the subsequent logic. You are hurt is the determining condition, and if it's met, the action go to the hospital is executed. In triggers, events and actions are necessary, while conditions are not. For example, go to the hospital as soon as you fall down without any condition. Without an event, conditions and actions will never be triggered, so blocks must start with an event. Without an action, the combination of events and conditions will not produce any triggering effect, so an action block must be placed in a piece of Eggy code. A trigger group is essentially the canvas we use when writing Eggy code. All triggers on a canvas form one trigger group. When writing Eggy code, we can write different system functions in different trigger groups for categorization. Different trigger groups run at the same priority level during Eggy code execution, so they don't affect each other. For example, a little Eggy trigger group might contain different triggers like you fall down, you are hurt, go to the hospital, and you have a fever, go to the hospital, with different triggering conditions that don't affect each other. Writing a large number of blocks in a single trigger group may cause the Eggy code interface to load slowly, and a large number of blocks can make it difficult to move the view to find target blocks. Therefore, using trigger groups to manage our triggers is necessary. Trigger groups can also effectively manage the large number of triggers we write. We can rename, copy, and disable triggers here. Clicking on a trigger's name in a trigger group automatically jumps our view to that trigger's position, so we no longer have to worry about finding a specific string of Eggy code on a huge canvas. It's important to note, as we explained when discussing global and local variables, trigger groups cannot share local variable. Triggers have three states: disabled, enabled, and running. We can disable an entire trigger in a trigger group. After disabling, the event block in the trigger cannot monitor the occurrence of events in the map. To reactivate the disabled trigger event, we can enable the trigger. Executes trigger block can ignores the event monitor and executes the trigger once. We can disable and enable triggers while writing Eggy code, and use related dynamic blocks to dynamically enable, disable, and forcibly run triggers during Eggy code execution. Object triggers on object prefabs are destroyed when the component triggering the event is destructed, and the destructed blocks can no longer take effect. When we directly enter Eggy code, we default to writing global triggers. Clicking the button in the upper left corner allows us to switch trigger types. Besides global triggers, we also have character triggers and object triggers. Object triggers need to be created by editing Eggy code for object prefabs in the object prefab section. Different triggers can write different logic, and the event blocks inside will vary. Global triggers are the main logic of the map and take effect at the start of the game, issuing commands to the entire map, whereas object triggers only issue commands to a specific object. Global triggers can be seen as a smartphone system, and object triggers as the apps we install. They run within the same map but do not communicate with each other. Global triggers are typically used to implement global logic. For example, after 1 second, initializes game. and object logic. For example, specified Eggy jumps, Eggy enter or exits specified trigger volume. Object triggers can implement logic for gameplay, such as a type of unit changing color upon collision, or a type of creature Eggy activating skills when enemies approach. In previous examples, we mostly learned about global triggers. However, if we want to grant abilities to all players, or write custom logic for a unit, using object triggers is more convenient. For example, if we want all player Eggies to create a heart effect at their location when they jump, we can directly use the character jump event in the character trigger. This way, this type of character, meaning all Eggies jumping, will trigger the event. Then, in the action block, we can directly fill in the character's location as the current character's location. This method is more convenient than specifying each player in a global trigger. Subtriggers, as the name suggests, are child triggers of a trigger created by the trigger. In Eggy Code, each time the logic runs to a subtrigger's position, a new trigger is created. Once created, subtriggers run independently, but if the trigger they are attached to is destructed, the subtriggers will also be destructed. The difference between subtriggers and global triggers is that subtriggers are created during the game process, allowing us to pass data from variables to the events of subtriggers.